Okay, again, we're going to be in section 8.3. If you want to follow along in the book, you can. I'm just going to kind of use this as a guideline. I don't know that I'm going to use it word for word, but we'll kind of show you that. Okay, and I got a whiteboard, so maybe it'll be a little more clear on your guys' part, so you guys can see just a little bit better. Okay, so we are in 8-3, which is polar forms of complex numbers. Polar forms of complex numbers. I'm sorry. Okay. Now, in general, a complex number is a number that looks like this. I'm going to say, I'll write out a definition. Is A plus BI. Complex numbers equals A plus BI, where A is the real part and BI is the imaginary part. And yes, I did say imaginary. This is where we get to the imaginary number stuff. In Algebra 2, you really just use those to resolve quadratics. And now we're going to get into the idea of how they can be written for polar numbers. Okay. Now, just as a side note, imaginary numbers are I equals the square root of -1. Okay. That's just, again, a side note from first semester. Okay. Can anybody recall what I squared equals? We're going to get to this in a minute. Adam, you remember what I squared equals?
I don't remember.
Gabriel, you remember what that is? Anyone remember what what I squared is?
-1.
That would be -1. Okay. We could actually go a step further. Anybody remember what I to the third is?
-I.
That would be -I. And then anybody I to the fourth?
Is that just 1?
That would just be 1. Okay. Now, we won't need all of those, but we'll definitely need these two as we get going here. Okay. Now, you're going to say, what the heck does this have to do with complex numbers? Okay. If I wanted to graph something like 2 minus 5i, I want to graph this. In our current structure, I don't really have a good system to graph an imaginary number. So what I'm going to do is I'm going to take this graph. The horizontal axis is going to be the real axis. Okay, it's going to be the real axis. And the vertical is going to be the imaginary. Okay. So in this case, the real part is 2. And -5 is the imaginary part. So I can kind of think of this like 2 -5. If I wanted to think of it in Cartesian system, it doesn't really work exactly like that. So I want to cross it out in a minute. But if I go 1, 2, and then 1, 2, 3, 4, 5, that point right there represents 2 minus 5i. Again, we want to be careful about this. It's not exactly the same thing, but it is close. Okay. If I were graphing, -3 plus I, which directions would I go there? Let me go to Ryan. Which directions would I go there? Ryan, can you hear me? Ryan. We do this next week. I'm going to have to make sure you guys all video, show your video and show your thing so I can hear everybody. Let's see. Trevor, I know you got in here late. Which direction would this one be?
You left 3 and up I.
So left 3, and then up 1. So this is going to be -3 plus I as this point right here. Okay. Now, this whole thing is called the complex plane. Let me scroll that up just a little bit. This whole thing is called the complex plane. Okay. And you can graph those just like you would, again, in a regular plane. Okay. Now, we're going to get a little bit more after we come back from our next break as far as the conversions from polars to this and all that kind of stuff. Right now, we want to just review some of our imaginary rules, okay? So let me erase this real quick. Okay, and this is the part you guys are going to say is a cinch. If I had 3 plus 5i, and I added that to 2 minus 6i, this is simply just straight combining of terms. Okay, Shelby, Casey, what do you think? What would I put together? I can't hear you, Shelby. I'm sorry. Well, this is just addition, right? So all I'm going to do is I can add the real parts. So 3 and 2, simply going to be 5. And then I can add or combine the imaginary parts. So positive 5i and negative 6i is going to be negative 1i. And it truly is that simple. Again, you're just combining the reals, combining the imaginaries. Okay. If I want to look at a different problem, let's say that I had 2 minus 4i. And this time, let's go ahead and multiply. Let's do that 3 plus 2i. Now, this one's a little different because I am multiplying. Okay. So this is just going to be a double distributive. Shelby Patton, what do you think here?
You do 2 times 3.
Yep.
Then 2 times 2i, negative 4i times 3, negative 4i times 2i.
Excellent. And then what is negative 4i times 2i? Let's go to Zane. Negative 4i times 2i is going to get me Adam, what do you think?
Negative 8i squared.
Yep. Perfect. So I got to deal with this. Remember, if you go back to our just a bit ago, what was I squared? What did we say that was the same thing as, Jenna?
-1.
So I squared was -1, right? So this -8 times -1 becomes +8. So what I have is 6 minus 8i plus 8. And I can combine those and get 14 minus 8i. I might need to look in to get some finer tip markers. I'm sorry if this is sloppy. I thought this would be clearer for you after I had some people say that it was a little too blurry the last time. Can you guys see this okay, or is it too messy?
That's good.
Okay. So that's just operations there. Okay, you can add, you can subtract, you can multiply. The division is where this gets a little bit messy. Okay, division's where this gets a little bit messy. So let's tackle that. Let's say that I have 2 plus 3i over 4 minus 2i. Anyone remember I have an issue with a part of this. What's my issue here? I got an I specifically where?
On the bottom.
I cannot have an I in the denominator. So that's an issue. That's an issue. So I've got to multiply by something very special here. Okay. Something that's got a special name. Anybody remember that name? Let's see. Jenna, you remember that name?
The conjugate?
Yes. What is the conjugate?
4 plus 2i.
4 plus 2i. And because we're talking about complex numbers, this is actually called the complex conjugate. Complex conjugate, okay? So really, I just got to distribute this multiple times, okay? Again, I multiplied by a special version of 1. So we distribute on top. So 2 times 4 is going to be 8. 2 times 2i is going to be 4i. 3i times 4 is going to be 12i. And then 3i times 2i is going to be 6i squared. Let me scroll this over just a little bit so you can see just a little bit better. Okay. All over. 4 times 4 is going to be 16. 4 times 2i is going to be 8i. Negative 2i times 4 is negative 8i. And then negative 2i times positive 2i is negative 4i squared. Okay. So this is going to equal, we want to be careful here. Over here, the 6i squared is going to become, I squared becomes negative 1. So 6 times negative 1 is negative 6. I'm going to go ahead and combine 8 and negative 6 to get 2. And then 4i and 12i is going to be 16i. On the bottom, something very specific happens here, which is the reason I use the complex conjugate. Gabriel, does your mic work or no? Maybe not. Ryan, are you still with us?
Yeah, I got it to work now.
Ryan, what happens on the bottom here?
The 8 i's cancel out.
The 8i's are going to cancel. What happens to this negative 4i squared, Ryan? So the I squared becomes?
Negative 1
So negative 4 times negative 1 becomes?
plus 4.
So that part's going to become plus 4. So 16 and 4 is going to become 20. Now, this reduces because 2, 16, and 20 all are multiples of 2. So I can reduce that to 1 plus 8i over 10. Okay. Now, you'll see this in your book, and I kind of go back and forth whether I think because general form should be a plus bi, that is definitely not a plus bi. I'm so sorry. That is definitely not a plus bi. So a in this case is really 1/10 plus b in this case is 8 over 10. 8 over 10 is a reducible fraction. I can reduce that to 4/5 I. So my a is 1/10. That's my real part. My b is 4/5 I. I've converted this to a regular number without the division. Okay. Questions there? Now, again, all of that is stuff that we've done in first semester. So hopefully this is a review. Maybe you've forgotten, but it's a review. We're going to kind of that's just kind of the algebra of imaginary numbers, complex numbers, and then we're going to stop. And then after we get back from the break, we're going to try to apply all this to polars. If you want to work ahead, you are more than welcome to, but you absolutely do not need to. If you want to go ahead and start an assignment, I'll post this assignment in just a second. We're going to be looking on page 538, and we're looking at 1 through 28. And again, I'm going to give you the odd. Again, we're just doing the computation there. Okay, just doing the computation there. Okay. Any questions there? Short and sweet. I will have you do this. I would like you to get this done today. Again, it's only 12 problems. Or sorry, 14 problems. It'll take you no time whatsoever. And then we'll see you after we get back from break. Thank you guys. Have a fantastic day.